In section 7.3, we are looking at some applications involving quadratic equations, and so we'll be solving applied problems with quadratic equations and solving a formula for a given letter. The first exercise is about landscaping, where a particular garden, rectangular, is 60 by 80 feet. Part of the garden is torn up to install a sidewalk of uniform width around it. Now we're told that the area of the new garden is 1/2 of the old area. And the question is, how wide is the sidewalk? So here's a little sketch of it. And so here's the original garden, 60 by 80 feet. And so now we have a walkway of uniform width x surrounding the new garden. And so when we look at this, we can see that the new garden has area 60 minus 2x times 80 minus 2x. So new garden is 60 minus 2x times 80 minus 2x. And the old garden is equal to 60 by 80 feet. Now the new garden is 1/2 the area of the old garden, so that area is 4,800 square feet. So we know that 60 minus 2x times 80 minus 2x is equal to 1/2 times 4,800. Or 2,400 square feet. Now we can simplify the calculations a little bit if we factor out a 2 from the first term and a 2 from the second term. So we factor out a 4, and that'll make it 30 minus x times 40 minus x equals 2,400, or 4 times 600. So we divide by 4 on both sides, so we have 30 minus x times 40 minus x equals 600. Or when we eliminate the parentheses, we had x squared minus 70x plus 1,200 equals 600. And when we subtract 600 on both sides, we have x squared minus 70x plus 600 equals 0. And we can easily factor this expression to x minus 10 times x minus 60 equals 0. And using the zero product property, we then find that x is equal to 10 feet. And the other solution, x is equal to 60 feet. So here we have two solutions, and so we need to evaluate and see which one makes sense, or maybe both make sense. So when we look at the width of 60 feet, and we're supposed to subtract 60 from minus 2x, or minus 120 feet, so in other words, that solution does not apply. So the only solution we have is x equals 10, and so that is how wide the sidewalk will be, 10 feet wide. So when it comes to application problems, in some cases both solutions make sense. In other cases, only one solution makes sense, or maybe none, but in this case one makes sense. So always evaluate your solutions. In exercise 2, a ladder leans against a building, as shown here. The ladder is 20 feet long. The distance to the top of the ladder is 4 feet greater than the distance d from the building. Find the distance d and the distance to the top of the ladder. So using the Pythagorean theorem, we know that d plus 4 squared plus d squared equals 20 squared, or 400. And so when we expand d plus 4 squared, we get d squared plus 8d plus 16 plus d squared equals 400. When we combine like terms, we get 2d squared plus 8d minus 384. So now we can divide by 2 to simplify matters. Divide the whole equation by 2. So d squared plus 4d minus 192 equals 0. And so that we can factor very easily into d minus 12 times d plus 16 equals 0. And when we set each factor equals 0, we find that in one case d equals 12 feet. And this, the second solution is d equals minus 16 feet. But distance cannot be negative, so this solution does not apply. So the distance d is 12 feet, and to the top of the ladder will be d plus 4. So the distance to the top of the ladder is 16 feet. That's d plus 4. For number 3, the ladder location, the only difference now is that the length of the ladder is 10 feet instead of 20 feet. So we can just jump to this equation here. D squared plus 8d plus 16 plus d squared equals 100. Instead of 20 squared, we have 10 squared, or 100. So for the 3 part here, d squared plus 8d plus 16 plus d squared equals 100, or 2d squared plus 8d minus 84 equals 0. When we divide this equation by 2, we get d squared plus 4d minus 42 equals 0. So that's our quadratic equation with a, b, and c. A being 1, the coefficient of d squared, b equal to 4, and c equals to minus 42. Then our solutions are d equals minus b, or minus 4, plus or minus the square root of d squared, b squared rather, so it would be 4 squared, minus 4 times a times 1 times c, which is minus 42, divided by 2 times a, or 2 times 1. So that's equal to minus 4 plus or minus the square root of 184 divided by 2. So when we evaluate the square root, so let's think about the solutions. 4 minus the square root would give us a negative number, and since we are thinking about distance here, so that doesn't work. So, but we can have d equals minus 4 plus the square root of 184 divided by 2, and that's approximately equal to 4.8 feet. So then the distance to the top of the ladder would be 4.8 plus 4, d plus 4 would be 8.8 feet. D plus 4 For the next exercise, marine travel, we have two ships make the same voyage of 3,000 nautical miles. The faster ship travels 10 knots faster than the slower one. The faster ship makes the voyage in 50 hours less time than the slower one. Find the speeds of the two ships. So the distance, of course, is the same for the slower and the faster ship. We talk about the same voyage of 3,000, so the distance will be the same. And so the speed of the slower ship is r, then the speed of the faster ship would be r plus 10. And similarly with the time, if the time for the slower ship is t, then the time for the faster ship is t minus 50 hours. So this then gives us the following relationship. Since distance equals rate times time, d equals rt, for the faster ship, r times the speed times the time would be r plus 10 times the time t minus 50 is equal to 3,000. And for the slower ship, r times t equals 3,000. So these are the two defining equations. So we can conclude from the second equation that r is equal to 3,000 divided by t. So when we substitute that for r, that value for r in the first equation, we get 3,000 divided by t plus 10 times t minus 50 equals 3,000. So now we multiply the left side. When we simplify this expression on the left side and subtract 3,000 on both sides, we get t squared minus 50t minus 15,000 equals 0. Now we can factor the left side into t minus 150 times t plus 100 equals 0. And now we have two solutions for t. The first solution would be t equals 150 hours, and the second would be t equals minus 100 hours. But time cannot be negative, so this solution does not apply. So then, since r equals 3,000 divided by t, r is then equal to 3,000 divided by 150. So r is equal to 20 knots. So we got r equals 3,000 divided by t, or since t is equal to 150 hours, then r is equal to 20 knots, 3,000 divided by 150, and that's for the slower ship. And then the faster ship travels 10 knots faster, r plus 10, so then the faster ship would be 30 knots. So slow ship, and this is the speed of the faster ship. In exercise 5, solve this expression for w sub 2 by squaring both sides. We get a squared equals w1 divided by w2. Now we multiply both sides by w sub 2, so we have w sub 2 times a squared equals w sub 1. Now we divide by a squared on both sides, so then w sub 2 equals w sub 1 divided by a squared. The last exercise asked us to solve the equation v equals pi r squared h for r, which is the volume of a right circular cylinder. So v equals pi r h squared. To isolate r squared, we divide by pi h, or pi times h, and so then the radius is equal to v divided by pi h. So that's equal to the radius, the volume divided by pi divided by h. So the radical symbol goes all the way down here. And this concludes section 7.3.